All right, everybody. Welcome to our brown bag on Blazor. I just posted a couple of options you have for viewing the slides here. If you go to just /qh/Blazor on that link, the first one, then you can control the slides and view them at your own leisure. If you want to go to the Blazor/live link, the second one there, I will be controlling the slide. So as I'm moving through here, your screen will also move. Or you can just obviously watch it through the Google Meet. So just to give you a little introduction, I am Quinn Heiner. I am a full stack .NET engineer, software developer at STG, Software Technology Group. Over 10 years now I've been with STG, and it's been a great journey, a great experience. So let's just dive right in. So we have a poll that Jen, okay, sure.
15 more seconds to finish putting it back in there.
So we do want to hear from you guys a little bit about your opinions of JavaScript. So we have a quick poll that we're going to take and kind of get a read from the audience. I'm going to kind of tailor my general attitudes toward JavaScript in this presentation based off of kind of how everyone feels about it. But while Jen's doing that, I will pull up the graphic that I was going to share. It's kind of hard to zoom in on some of these slides. So a couple of these I actually have separate things for. So I'll be doing that while Jen's getting the poll ready.
And it should be there. You should see it.
So in the bottom right of your screen, I think there's a little dot on the thing that says activities. And then under polls, you should see a poll that says, what is your opinion of JavaScript? So go ahead and take some votes here. And don't get worried. It says your name and everything will be recorded. We're not going to share these results with your employer or anything like that. And your name's not going to be identified. It's just the aggregate that you're going to see in terms of how people vote once the poll's closed. But go ahead and vote while I'm loading up the next part of the presentation here. We'll give you just about a minute because we got a lot to go over, obviously, in just an hour. So we will try to move things along. This one. Okay, anyone having problems getting to the poll or voting or anything like that? Speak up now. I'll give you about 30 more seconds. Bottom right of the screen, there should be some shapes. It says activities when you hover over it. Click on that and the poll should be there. I'm already getting, I got to close out this Jabber chat. People at work are already sending me disparaging messages as I'm presenting. I love it. Okay, let's go ahead and close it. See where everyone's at here.
Okay, see the results?
Okay, wow. We have a divided audience. This is going to make this presentation a little bit trickier. So a lot of people, looks like we're pretty split on people that have no opinion one way or the other. A couple of thumbs up. Yeah, it's quirky, but overall I like it. And then about 6 people that either think it's frustrating most of the time or hate it with a passion. So wow, I was expecting a little bit more of a consensus, but we'll go with that. So really quick, JavaScript, most popular programming language in the world, and that's a blessing and a curse, and I'll show you why in a second here. It is the programming language of the web. It was invented in 10 days. That's the romanticized version of it in 1995 by this guy. I know, nerd alert. So JavaScript is weird. If you were to copy this into your console, And just for kicks, I try not to do too many of these live unprepared things, but I'm just curious if it still works for me. You betcha. Look at that. This is an illustration of the code never lies and how weird the language can be. You type in this kind of stuff, you get weird answers. So it's crazy. And I think some of the problems stem from the fact that it is the biggest scope creep in the history of languages. You know, we have all of these problems that JavaScript is trying to solve. You know, hey, there's no standard library. It won't run outside the browser, but the DOM is too slow and I want to play video games. So they have all these different solutions, right? We have, okay, well, they start to go down these paths and they say, okay, well, what about, you know, Grunt and Gulp, and what I want to be able to run JavaScript on the server with Node, and I want to do all these other things. And you get down to, well, JavaScript still isn't doing everything. And so, okay, let's do Electron, PhoneGap, Firefox, all of these things. And you start to realize that JavaScript was never intended for this kind of stuff. And you're kind of, you know, digging yourself into a hole, so to speak. So overall, my opinion of JavaScript is has a lot of good points about it. The functional aspects of JavaScript are very powerful. Obviously, as DOM manipulation, the original kind of intent of that, you know, it had some strengths, but there are a lot of weird idiosyncrasies in the language. And so it is hard sometimes to quit JavaScript. I mean, let's just be honest. But so we're going to talk about today Blazor as an alternative to just JavaScript, and kind of answer the fundamental question of the brown bag is, can we write a web app, a commercially viable web app, not just a hello world demo kind of thing, and not have to use JavaScript? And the short answer to that is yes. So we're going to talk about Blazor here, as it is an open source cross-platform web UI framework. It does use C# for the DOM manipulation stuff. And what's amazing about this, and this is where kind of the criticisms of Blazor come into play, is, okay, well, are we just talking about another Silverlight? You know, that is the thing, is Silverlight alienated a lot of people because there were a lot of people that were invested in XAML and being Silverlight developers, and they spent years of their, you know, technical training getting up on it, and then Microsoft abandons the project and completely leaves everyone else kind of going back to another solution for front end. Blazor is different in that it uses WebAssembly. It is not a plugin. That's the key difference. The problem with the plugins and with Silverlight applications, yes, they were these beautiful, sexy desktop-like experiences from within your web browser, but it relied on a plugin. And a lot of that, with the whole Flash thing and battery consumption on mobile devices, kind of killed a lot of that. But you see here, WebAssembly, this caniuse.com is always a great way to check browser compatibility. You're seeing that running native WebAssembly, in this case, WebAssembly being native C# code in the browser, we have amazing levels of support from 99% of the browsers. So in terms of compatibility, unless you're on a really old legacy application that's targeting a specific version, or IE, which is gone pretty much now, but it still kind of, you know, shows its ugly face in global usage, 0.5% still are on it, IE 11, for example. But other than that, you've got really good support for WebAssembly. And even if you don't have support for WebAssembly, there are options we'll talk about in a second. So it is single page application development. So in other words, when you are, when you're looking at a page, you know, your URLs are changing like that. I'll show you quickly here. This guy. We'll talk about the demo application in detail in a minute here. But you can see as I'm going through and clicking things on my network tab, you can see up here the URL. For example, we have customers, we go to details, we're going to orders, you know, you're viewing all of this data, you know, URLs are changing up here. But you know what, the only things that are changing over here is just web API calls. The actual HTML is not being reloaded or anything like that. It's very much a single page application that your front end frameworks are seeking to solve, right? And it's a lot more efficient, and it's a lot more less jarring of a user experience. You don't see a bunch of pages reloading and big blank screens and things like that. So it is very much in the same vein as Angular, React, and Vue. It's kind of Microsoft's answer. So now we have a full end-to-end Microsoft solution if you want to. Previously, we had to deal with front-end frameworks being, or JavaScript at the end of the day being our front-end technology. And then we had to kind of shoehorn that into the Microsoft stack. And now that's just not the case. And it is a first-class citizen of the .NET framework. So it is now built in and supported by the .NET framework. So you don't have to worry. It's not going to be going away anytime soon. It's not a fad, or a lot of the negatives about Microsoft in general is that they'll just abandon projects. And I just don't see that as being the case. We've got lots of third-party vendor support. We've got an amazing community, and it's open source and cross-platform, which is going to still, by default, I think it'll be stable over time. So we got reusable web UI components, which are just Razer files, and we do C#, HTML, CSS. And it's near native performance, especially in WebAssembly, as we'll see here in a second. So back in 2018, it was an experimental project. Then we released Blazor Server, I think in September 2019. We'll talk about the differences here in a second. Client-side Blazor came out during the pandemic officially in May 2020. And when we say client-side Blazor, we're talking about WebAssembly. And then in November 2020, .NET 5 came out, and it was officially kind of released as part of the framework. And now we're on .NET 6. Every year now, Microsoft is releasing the new version of the .NET framework. We're all the way to, this coming up year will be .NET 7, .NET 8, and every other one, .NET 6 being a LTS or long-term support release, every other release will be supported. So in a nutshell, what Blazor does is very similar in concept to your components in Angular, React, and Vue. What you have is a components within components within components. And sometimes, we'll talk about this more in detail in a second, you can have a page which corresponds to a URL. So it will basically, as your routing matches that URL, it'll try to load the component. And other times, we just embed it right in the HTML. Think of it as just expanding the HTML syntax and saying more of an XML-like experience where I can make up my own HTML elements and name them the name of the component class. So for example, here on the left here, you see the dialog title Blazor, and then you have a dialog Blazor here. And then you can do your code right there in the Razer template, or most of the time we will separate that out into two files. I'll show you the differences here in a second. But the coolest thing about this is you have this, for example, this button on-click message on yes. This is C#. This is not JavaScript. It is all being done in C#, which is pretty amazing. So I got to be intellectually honest about Blazor as a consultant. We always joke about, we're opinionated. We want to push an agenda. We want to do things our way and use our tech. But there are some use cases to not use Blazor. So I really wanted to go over those very quickly. If you're a Microsoft shop and most of your team skills are C#, I would highly recommend Blazor, especially for greenfield projects. If you want to be a full stack Microsoft shop with that support level from Microsoft, this is a great choice. And it's much easier to transition for folks who have been doing web forms or MVC. The transition to Blazor is exponentially, it's easier to learn. The learning curve is much less steep than Angular, React, or Vue, in my opinion. I've done plenty. I've started out in raw JavaScript, moved to jQuery when we were attempting to standardize JavaScript across the browsers. I've done web forms, I've done MVC, I've done Angular, React, Vue, and now Blazor. So I've been through that whole journey, and I can say pretty objectively that Blazor for a C# developer is much easier to learn and transition to. When shouldn't I use Blazor? Obviously, we talked about this briefly earlier. If you have a legacy web app, may not be compatible. If you have, you're targeting IE, for example, or something like that, you may have some issues there. You may already have a dedicated front-end team that already uses Angular, React, and Vue, and you've got a great system in place, and you've got you're willing to constantly be updating that, because obviously the release cycle on Angular, React, and Vue is much quicker. Every 6 months, you could have breaking changes. So you need to have a dedicated team, a front-end team for that. Blazor is much newer than the other frameworks, as we'll talk about when we talk about third-party component libraries. Yes, there's a lot of them out there, a lot of commercially viable ones that are great, and definitely are getting to that direction, but you still don't have that established timeline of some of the front-end frameworks. So maybe it's a little bit more experimental at this point, even though Blazor is no longer in as a release candidate mode. It's very much ready to go. It's ready for prime time. So really quick, before we get into the fun stuff, I just want to talk about the flavors of Blazor. So you really have two options at the end of the day with Blazor. You could run it on the client or the server. We call it the client version Blazor WebAssembly or WASM, either one, or Blazor server. Now, the thing with Blazor server, and these are just different ways of kind of hosting, if you can think of it that way, but at the end of the day, we'll show you in a second, there's not that much difference between the two if you design it right. Blazor server does not use WebAssembly. And so this is more of your traditional, web forms, MVC type of thing, where you're much more involved with the server. The server makes those decisions and will basically render those differences. Whereas WebAssembly, it's all done on the client, more similar to your front-end frameworks like Angular, React, and Vue. So we got a lot of great Pluralsight images that I copied for these, but basically Blazor WASM, this is one thing to remember, is that the .NET Core assemblies and runtime are downloaded initially to the browser. You do take that hit up front. But what's great about it is once everything's in the browser, it's much more, it runs very smoothly because you've got everything running in the browser, right? But this is what's kind of trippy for me and for people that are getting into this for the first time. You literally have DLLs that are on the client, that are in the browser in this case. And so that kind of, you've got to have a complete mindset change of, we're no longer loading some other asset like JavaScript or something like that. It really is the actual .NET Core runtime. It's a version of the runtime that runs on WebAssembly. So another way to look at it, you can look at these slides later. We don't want to go over these in too many details because I want plenty of time to demo, but you do have, with WASM, you do have two different modes of hosting. Obviously, you need somewhere to host your code. When you go to create your project, you have the option of hosting it on an ASP.NET Core backend, or you can do a standalone approach. If you have like a static website in Azure or something like that, or a backend API that's built in some other technology, that backend can be completely separate from your WASM application, and you can have a standalone way. So you kind of think of it, there's two major flavors of Blazor, Blazor WASM, Blazor server side, and within the WASM, you have these two options as well. So Blazor server, like I mentioned, it does not use WebAssembly. So maybe some of your older technologies, older browsers that you're targeting, and you don't want to have to deal with the WebAssembly side of things, but it does need to support SignalR, which is even more browsers are on board with SignalR than with WebAssembly. You're still talking 99% in either case, but with Blazor server, what we have is the SignalR is basically what is responsible for doing the diffs on the page and sending down those diffs in the HTML, in the DOM, the document object model, which is that live representation of the HTML running in the browser. That code is all handled through a SignalR connection. So you do have to remember there may be some scalability problems here because you are tied to a server. However, Azure and a lot of these other tools now, scalability is not as big of an issue as it used to be, having that dedicated server connection. So basically, you've got, again, WebSockets managing that real-time, those UI updates. What's important to remember in these two approaches is that it is completely seamless to the user. The user does not know the difference. It is still a spa at the end of the day. They may see some things taking a little bit longer to load in server side. You do a call or whatever to get those updates, maybe a little bit more sluggish, but that upfront hit is not going to be as big because unlike WASM with Blazor server, you're not downloading all of that .NET runtime initially into the browser. So it's almost, do you take the hit now up front with WASM, or do you take the hit later in terms of performance or as you're going through with Blazor server? So here's a good illustration of the differences of how it would look if you were to do a server-side Blazor versus WebAssembly. Really, if you notice here, a lot of the components are exactly the same, but you're going to see a few key differences in the actual bootstrapping of the Blazor application. On client side or WASM, you're going to see an index HTML. In the server side, you're going to see that host CSHTML. But it is essentially the same product. And you also obviously have a startup on server-side Blazor since you have that dedicated server connection. Client side, it's all going to be run in a program CS. And your web API or whatever could be Kestrel. It doesn't have to be IIS. It's still not tied per se, because you still have that option as a standalone approach in addition to ASP.NET Core hosted. So to the end user, they're not going to see a difference. To us, again, if you design everything that's not, if you design all of your web API calls and things like that in a very generic way, which I'll show you in the demo, there's actually not a lot of effort to switch from one to the other and kind of try an A/B comparison to see what works best for your needs. So we talked about the benefits and downsides kind of off and on, but you guys can go through these later when you're trying to make the decision of whether to do WAS and Blazor or server side. And then here's another Pluralsight image that I thought was very helpful as well. But the bottom line is they're both great solutions. They both work very well. That biggest thing is that upfront hit with Blazor WebAssembly. And if you need an offline experience for your users, obviously Blazor Server is not going to work because you have to have that dedicated server connection in order to make it work. So if you guys don't know which one to use, as a consultant, I say generally you want to start with Blazor WebAssembly. Most of your scenarios, you can do it with WebAssembly. You don't need that Blazor server version. It just, again, that's just my recommendation if you don't know where to start, and then you can move over and convert, obviously, if you need to. Okay, sorry, I went through a lot really quickly because I want to have plenty of time to demo and see how all this stuff works. But let's take a second. Does anyone have any questions, or have I been missing the chat window? I haven't been keeping up. All right. Any questions before we proceed? Okay. Okay, let's talk about the demo app. So this is, just one second. This is actually the, so STG has in-house certifications. And the nice thing about these, it's not just a multiple choice test like a lot of your certs. It is peer reviewed. You do pull requests. You have a, second set of eyes on things. And this demo app was built based off of the requirements of that certification. So we kind of get a 2-for-1 deal with this demo. Of those of you who are STG employees that are interested in doing the certification, this may give you a jump start on some ideas for how to architect things and how to get things going along. So the source code, I'm not quite sure exactly sharing the details of that. I'm not quite sure what our policies are. So you can get with me after if you do want to see or have access to the source code if you're not an STG employee. So really quick, the demo app, I'm just going to show you a brief kind of overall structure to kind of understand what's going on. And then I will show you some features in the app, and then we'll reverse engineer that and show you how it's built in Blazor. So basically what we have, very straightforward database structure. I'm sorry, this is kind of small to see, but it's just a customer and orders database, your standard kind of demo application where you have a 0 to many relationship of customers who have orders, and each of those orders are associated with 0 to many order items, which are associated with the product. So not a whole lot of business logic or anything like that, but just basic concept of a customer with orders with line items that are associated with the product. So in terms of the project structure, the way we've organized it is we have the client layer, which is this case will be Blazor WebAssembly code with your Razer components. Then you have the data layer, which is actually going to be your entity framework, standard repository type stuff that will talk to a SQL Server database. And then you have server, which is going to be all of the web API side of things. And remember, when we're designing these, now that we're in the Blazor world, your web API is no longer going to serve up. It is a true web API that's a data service. It's not going to serve up pages or views or anything like that, like you normally do with like web forms or MVC. It is truly just literally a web API that serves data. So what we have here, I could just show you really quickly, just your standard CRUD operations. We're not talking like CRUD as in like you step in a pile of doggy doo. This is create, read, update, delete. So we have each of those on these various items. So CRUD operations for customers, orders, order line items, and some search capabilities as well. Again, very straightforward URLs. RESTful web API as you would expect. Then we have services, which is the layer that will be between your API and your data layer that we'll talk about in a second, and then your shared models. These will include view models that are specific. If you notice here, on the Swagger documentation, all of these models that end up being, that actually get sent out over the wire are view models. They are completely decoupled from your shared domain models and your entity framework, POCO or plain old CLR object classes. So that will be part of the shared layer, is we have both domain models and view models that are shared across projects. So what that basically means, think of this as kind of an N-tier application, but I want to show you a key difference in how we're achieving a little more encapsulation than you normally would see in a program. We have each of these layers are only accessible through interfaces. So at the end of the day, your client's going to be working with your view models, but then as we call the web API and call the app services, they will always be shared domain models, if you will. I know my DDD people might not be considered pure domain models, but at least it's a step in that direction. And then your data, your entity framework layer will be with entities. But as we look at the project, so I'm going to hurry and show you the code here. We have, when you open up any one of these projects, you'll notice everything under here is normally what you would see, as a lot of people tend to make these public. So like your DB context and stuff like that, everything in that internal folder is very much internal to the assembly. So all of these entity classes that are basically kind of a one-to-one relationship to the database, they're all internal. You can't get to them from any other projects. The only way that these layers talk to each other is through the interfaces. So we have basically our CRUD operations, and we're always asyncing, awaiting them, returning tasks instead of the actual data, so that we can achieve that scalability and not lock up threads and things like that as we're trying to access and scale our API. So basically what we have is all of these projects have that same kind of structure. So if I go to the services layer, everything, all of the actual service methods. So in other words, you're not going to be able to new up a DB context inside your presentation layer. You're not going to be able to just new up a service class. You always have to go through the interfaces, because those are the only things in these projects that are public. And that helps us achieve some more encapsulation and helps developers to not do dumb things and mix up the layers and mix up concerns and things like that. It keeps the code a little bit cleaner. So in other words, you're never going to talk directly to the repository layer from the API, from the client app. You'll always talk to it through the interfaces. Okay. So with that, let's go back here. I did want to mention, just kind of as a shout out to C# 10, there are some amazingly kind of one of those, there's a lot of features in C# 10 that just make your code shorter and shorter and get fewer and fewer lines. The coolest thing is your program CS, your console write line is now 1 line. And I love how we're no longer indenting things just for a namespace. You can now have file scope namespaces, which is really awesome. So one real quick thing, it's kind of a side thing I wanted to demo though, is if you look at any one of these, let's just pull up a random, repository class, for example, or like a DB context or something. All you have is the namespace, and then everything else left indented like this. You don't have all of these other things, and you don't have any using statements. All of your using statements can be put now into a global file, this guy here, and now you never have to play this game of a copy and paste some code, or I'm doing a lot of moving around and things like that. It'll just know to look here for your namespaces. And it's kind of a nice thing because it eliminates a lot of the extra clutter and stuff in your code. It can be a curse in that sometimes you don't know up front where things are coming from. You kind of have to mouse over and kind of F12 into things. But in general, I'm finding you can get a lot more done in fewer lines of code with C# 10. So I just wanted to make that side note there. So when you're getting started on a Blazor project, there are a couple of things that I wanted to mention here. One is this concept of multiple startup projects. So if you are hosting your API in the same project and you're calling and it's .NET Core hosted and like that, and you want to run it locally, the very first thing you're going to notice is that you're going to have to be running your web API and your client project at the same time. And so what I would recommend in that, let me show you really quick here. You're going to want to go to this set startup projects within your solution, and you're going to actually want to start. And if you don't want to step through code and have breakpoints and things like that, you want it to run a little faster, you can start without debugging. I like having both if I ever need those breakpoints. But your web API, in other words, your server and your client, you're going to want to start them both at the same time. Now that also lends itself to another issue that you're going to have, where you're going to need CORS, cross-origin resource sharing, set up, because by default it's not going to let it through. So what I recommend is in your launch settings, I get rid of all the IIS ones. I don't want those ever to run an IIS. And you have your server here. You're going to want to make sure your application URL is set. And then that way, when you go to your API project, so this is the server project running on, whatever port you want. And then when you go to your client project to run it, let's see here. Launch settings here, you're going to want to run it on a different port so that you can run both side by side. But then in your startup, in this case, your API startup, you're going to need to add, the reason why I like having a specified port every time rather than just letting the framework decide for you is now I can add my CORS projects here, and I can say, okay, this is the origin that I'm going to allow all the web APIs through to your client layers so that you can be up and running. So that's the first thing. The other thing is creating components. So when you go to create a component, like I said before, you have that option of having that inline code, but most of the time that just doesn't make sense. Going to want to separate those out. You have a couple of different ways of doing that. So what I would recommend is, let's go up to here. We're gonna talk about components in a little bit more detail here, but when you go to create your components, you can do a base class and just have it inherit, but I like doing .razor and .razor.cs for your code behind. And as long as that code behind inherits from component base and it's a partial class, then .NET, at least in .NET 5 and up, you will actually, it'll group it for you, and it'll be kind of a nice more way to contain things. Sometimes people like to prefer the base class route, where they'll just have a class that inherits from, customer add base or whatever your component name is. But when you go to create a component, I always just create two files. I'll just do the Razer file for the actual template data for the HTML, and then I'll do my code behind with a .cs as a partial class that inherits from component base. So those are kind of the two caveats to get started. In terms of the feedback loop, this is one thing that's kind of new and experimental. You will find that this hot reload here thing is your friend, and especially in VS 2022 and the newer versions, it's getting better and better every release. But what you'll find is this is a key difference from your front-end frameworks. So let's go ahead and run this. Your feedback loop, this is where Blazor is a little bit at a disadvantage at this point in the game compared to your front-end frameworks. With like Angular, for example, you're typing in your template or your code behind or whatever, you hit save and that automatically refreshes that browser. Well, sometimes in Blazor, it's a little more complicated because you're dealing with C#. So let me just show you really quickly, kind of illustrating the pain points here and how that can be overcome. So let's go to the customers list here. Actually, let's go to the page. So I'm just going to try to make a change here. So if I go to the app, so you see here on the header, for example, we just have customers, right? Well, if I try to go and change this and edit it, and I hit save, nothing happens. And if I refresh the page, nothing happens. So this is one thing that you'll get used to in your feedback loop, is that most of the time, if you're just making small incremental changes to like a template, or even on the C# side in your code behind, hot reload, I would say about 50% of the time will work. And the way you'll know that it's working is once I hit hot reload, you'll see down here in the bottom left, you'll see that the changes were were applied. If it's, yeah, right there, you'll see code changes were applied successfully. You'll see a checkbox over here if you're looking at the app to say that it refreshed, and then you'll see your changes. So most of the time, hot reload is just about as quick as an F5 as your normal refresh of the page. But you'll get other times where, you know, you'll want to add a property or something like that. Let's say I want to get a little more fancy and I want to say, you know, I want to add something here. I go to refresh, and then you'll get this message. Say, hey, this is a little bit too complicated. I can't just hot reload your changes into the code. So you're going to need to rebuild and apply those changes, which again, the feedback loop is still really fast, fairly fast. It's not quite as fast as your refresh, but you'll notice here the build starts, and then it will just start right back up from where you're at. And you'll get warnings in your compiler and stuff like that, whether you need to rebuild it or not. But the nice thing is sometimes in your C# code, you'll still be able to make changes, especially within methods and things like that, and it will hot reload it for you. You don't need to rebuild. So just depending on that, just be aware of those nuances as well. Okay, anybody? I have not been checking the chat. Any questions along the way? I'm not seeing anything. Okay, let's see. Sean, the hit for downloading assembly is each time they visit the site. No, it would be if they were to clear their browser cache, then yes. Do you have to use code behind? No, you don't. But 99% of the time you're going to need it. So, okay. Okay, so hope that answers the questions that are going on in the chat. So we got quite a few features I want to go over real quick. We're about 20 minutes left. I'll try to end a few minutes early for questions. We'll see how far we get. First off, we're just going to talk about the different component types, page versus template, how to get from page to page, very simple concepts, passing data to components, managing events and dependency injection, maybe some form validation. This is the goal of what we want to get through in the next 20 minutes. And then we'll have a little bit time at the end for some questions and things like that. All right, so in terms of actual getting to components, you basically have two options. Like I said earlier, you can do a page component, and all that involves is this magical @ page, and then you just give it the route. And what will happen is as soon as your page loads, it's gonna look at that route and it's gonna match it to the component and it's gonna render. So, and the nice thing about that is that's basically it. You know, there's a lot less ceremony in C# than there is in TypeScript, for example, or JavaScript, or whatever framework you're using. If you're doing your front-end frameworks that are JavaScript based, you know, you have to register your routes, you have to register your components in a module, and you have to export them, and you have to do all these things. There's a lot more ceremony than there is in Blazor that I've noticed very quickly in my kind of switch from one to the other. Because once that's up there, luckily, because it's C#, the framework's able to recursively look at those classes and create those routes on the fly for you. Now, what's nice about that is you can also write. So that's one way of getting to the component. The other way is, you notice here, you have a component. You just name it the name of the class name and put it right into the HTML. And then anything that starts with an @ is basically your way of saying this is a C# expression. This is, you know, whatever properties I have on that component that are public, we'll talk about in a second, that are parameterized, I can actually specify my stuff there. And I can F12 on this guy and go right into the component that it's talking about. In this case, it's the customer list. So this guy here. Let's talk about going from page to page. So actual routes. So if you notice here, I'm on, you know, /customers is my URL. These are my basic CRUD operations. So this is the same kind of thing on customers, on orders. Let's see if I can find one with more than one. Yeah, this guy has quite a few. So this is kind of my read operation to view the details of an order. You see these URLs are changing here. We can drill down to a specific customer with their specific orders. We have line items that we can do CRUD operations on. And at the very end, we can view that invoice as well. It basically kind of accumulates all that data together. So these represent the line items of the order. You have a quantity and a price and all that kind of stuff. And when you edit, let's actually do this all from the customer page. So we can just do one thing at a time here. So on the customer page, for example, that was my read operation. I've got my edit, which pre-fills the form, and I've got my delete. And I can add new as well, my create operation. And I've got my form validation as well. So we're going to kind of reverse engineer this and kind of go through how this is all wired up. So when I go to a route, so now what is the code involved to go from /customers to /customer/ whatever the ID is? The nice thing about Blazor is it's basically one line of code. So what we have here is on my customers component, or customer list, sorry, you'll have a navigation manager, which is built into the framework. And what's nice about this is whenever you have services that you need to inject, it's a little bit different of a mindset, but you can't do it through a normal parameterized constructor, like where you have it, you new it up or whatever, you do dependency injection. What's nice is if you just annotate it here, whatever mappings you have in your startup or your program CS are going to automatically be there and ready to go. You just have this inject annotation and it will automatically wire it up for you. So what we basically just have on that click event, if you go to the actual component here, right here, right here, we have a click event that just calls that method. And the only thing I'm doing in that method is navigation manager.navigate to, and there you go. It's just that easy. So now if I want to view, what about parameters? How am I passing parameters to things? All you have to do is if you have, this is not a good example because there isn't one, but like for example, on customer detail, I think has one. So customer detail, when I have the drill down here, has this parameter that's being passed. And as soon as you annotate your property, that means it can be passed from the parent component to the child. So in your HTML, you can actually pass this guy in through the code and it will wire it up. And so that's basically all you need to do to parameterize it. Now, if you're going the other way, we have what are called event callbacks. So now you're saying, hey, something happened, usually an action happens, and you want to be able to notify the parent component that something happens. You can do what's called an event callback, and then in here, you just await and invoke async. And what that will do is now on the parent component, you can have whatever the name of it is as an event, and you can have that as a callback function in your parent component. So it's very straightforward in terms of being able to pass data back and forth from parent to child, child to parent. Very, very minimal code. In terms of dependency injection, we talked about that. Form validation. So what's nice about form validation is you don't have to recreate your view models in TypeScript or JavaScript, whatever you're using. It's all now integrated. So for example, on your, I can look here at the shared here on customer detail. Actually, let's look at this one, for example. So when you're adding a new customer, save here. You can use data annotations. So you have, this field's required. This has a max length. You can create your own custom data annotations as well for validation. It's very straightforward. You can also have custom, if you implement iValidatable object and you want to compare across different properties. For example, I just had this rule here say, hey, you can't use a test email account. You can yield return that and it will automatically show up in your list of error messages as well. So this code runs every time. The way this validation is wired up to the form is, if I go into customer add here, you have a couple of different options. The easiest one is you have this data annotations validator, which enables those attributes to be put in there. And this is built into the framework as well. And you can always tell when you hover over these, you can say, hey, it's part of the .NET Core framework because that's the namespace, right? And then at the very bottom, so you can have these validation summaries, which are also built in, that will have the error messages that pertain to that particular field. And then you have a validation summary at the very bottom. So that what that corresponds to on the app is, it's probably not the best one here. Let's go back to customers. This guy right here. Now you notice that that custom validation attribute about the test email address, it didn't fire yet. But as soon as you get into, if you've filled out these other fields, it will run eventually. It just takes a little longer. So you have, I think it was test.com. Then you see that also gets run as well. And again, this is all without having to do some callback to the server or anything like that. It's all run on the client. So this validation summary, both at the model level and at the individual property level, in addition to that data annotations up there, gives you all of your form validation that you could ever need. Okay. All right. Questions so far? I have not been checking the chat group here. Okay. You can also use .NET Watch Run, and the hot reload works really. Yes, very good, Troy. Yeah, you can do that as well. But yes, you won't be able to hit your breakpoints. That's the killer. That's the caveat to that, right? Okay. Any other questions before we proceed? We're making good time. So how do we call web APIs from your Razer components? The nice thing is it's very straightforward. So for example, on the customer detail, obviously we need to get all of that data. So as soon as there are several lifecycle events, but uninitialized async is pretty much your go-to one. When that component is first newed up, for lack of a better term, then you can set all of your property names that you're going to bind to in your Razer templates. So what you can just do is say, hey, customer equals this. And this is literally all you have to do. You have an HTTP client, get JSON, bind it to the view model, and return it. And this calls your web API. So most of these, now, again, you may have some more advanced business requirements or something like that, where you may want to do a service that kind of encapsulates this HTTP client call. I don't have any problems personally directly calling HTTP client from your component code behind. Other people may want to abstract that away a little bit more, but either way, you can inject an interface that actually calls the API. But for me, for most of your CRUD operations, keep it simple. Just call the URL and get your data, and it automatically binds. Now, again, this is one-way binding, right? So the code will update your model that you see on the screen, but it doesn't go two ways. If you want, the only time that you really want to do that two-way binding usually is in forms, where you say, hey, if I update the model on my end as on the client, then I want the underlying model to update as well, right? You want that two-way street. And if that's the case, then, sorry, right click here is not working very quickly. Go to page here. In that case, you have these kinds of things where you do bind value, and this will achieve that two-way binding of saying, okay, now I can update the model in addition to the model updating me, if that makes sense. Okay. What's pretty amazing to me is how few lines of code I'm able to do a lot of these things. And granted, we do have a third-party component library that we're kind of tapping into. I'm using Radzen. We'll talk a little bit more about third-party options here in a second. But for example, if we look at a grid, like that customer list grid that you're seeing, I haven't done any kind of special wiring up or infrastructure or anything like that to wire up the grid. All I'm doing is getting my customer data from that API. I have a few query params to page it and things like that. And that's pretty much it. Once I'm inside the Razer component here, you just have a few settings that you have for your grid. What's nice is all of these properties are strongly typed. And in 95 lines of code, we have a full-blown grid with CRUD operations on it. And the code behind for those CRUD operations is also under 100 lines of code. And for me, the true value of a framework is how much are you fighting against it to do simple tasks, which with Blazor were very few for me, but also how many lines of code does it take to accomplish something? Because maintenance over time and backwards compatibility and all these other things, the fewer lines of code, the better. And so for me, Blazor has been a really good experience because a lot of these things would have been hundreds and hundreds of lines of code in some of your front-end frameworks. And like opening dialogues and things like that, you have a dialogue service that comes with your third-party component library, most likely. You literally just open it, the name of the component, pass in some parameters, and you're good to go. And then coming back from the dialogue, like we talked about earlier with your event callbacks, you will sometimes, for that data binding to really update, you do have to call status change, but that's built into the component base. And then you just do whatever calls you need to once that, that child component or that dialogue or whatever needs to send data back the other way. You have your event callback that handles that. So very straightforward. See what we got here. So I know we're getting short on time here. There are some additional features that we didn't cover. Authentication authorization, I was going to start doing demos on that, and I realized we're just not going to have time for it. But just to give you a few nuggets of knowledge here, there's a great Pluralsight course that talks about it. But most of the time in your actual templates, you have different versions that you could say, hey, are they authorized or are they not authorized? And this will go off that built-in authorization framework that you get from .NET. And then if you need to programmatically check authentication for things on the front end, you have this authentication state. And you do need to do it as a cascading parameter. The difference between that and the regular parameter we talked about is this will, if you have a grandchild or great-grandchild kind of component hierarchy, kind of that level, and you want to pass those parameters down implicitly, you can do that. And then you can check your as soon as you got .user.identity, this is the standard .NET framework stuff that you have. You have access to that in the template. So there's a lot of ways to do that. Obviously, OIDC, OAuth 2 and OIDC with your token, your JWT token, is the preferred Microsoft way to do authentication authorization. And there's some great courses on that as well. Also, I didn't have time to talk about JavaScript interrupt. So I did cheat a little bit. Sometimes you do have to, you find yourself, you're butting up against a Blazor library that just doesn't have everything you need, and you're forced at the end of the day to run some JavaScript. You can actually call JavaScript straight from your C# code in just a couple of lines. You do this, you just inject this into your template and run invoke async, and you can strongly type what's coming back from that, pass in your data, and you're literally calling JavaScript from C#. What's cool about this, you can also call C# from JavaScript. So you, with this JS invocable stuff in your code, you can actually have JavaScript that will, you basically just namespace it here, invoke your method, and it will literally do it the other way. So what's nice and powerful about this is you can, if you have a library that you're trying to expose, you don't want them to have to run JavaScript, but under the hood, maybe you do need to do a little bit of JavaScript. You can expose that as a NuGet package, but everything at the end of the day is going to be through C#, and it can be seamless and more consumable in the C# code to be able to call that JavaScript. So sometimes you might find yourself having to do that, especially as you go through things and find that Blazor frameworks, Blazor libraries, they're a little bit newer. So sometimes you do have to cheat a little bit. And I think it'll be less and less as time goes on, and you have to cheat and call JavaScript sometimes, one way or the other. So in terms of learning more, choosing a third-party component library, there's a great article by John Hilton that I wanted to link for you guys of the questions as a business you need to ask when you're choosing a component library. There are a ton out there. There were 9 that he went over. These are the kind of the main top ones that I've found. Radzen is free, easy to use. I didn't have to really learn much about their framework to be able to consume all their stuff. Sync Fusion is a little bit more of a enterprise solution. They do have a community edition that's free, but it is a paid product. And then you have a lot of other ones in the game. Telerik, Dev Express, these are kind of more established third parties as well. They do have Blazor components that work for both WASM and server side. In terms of learning Blazor, I do recommend, if you really have the, if you learn well through videos and downloading code samples and things like that, Pluralsight has a learning path that's specifically for Blazor. It's about 18 hours of video, but you do have an interactive project, but the interactive project's super quick. You can get through it in a couple hours. STG, obviously, I mentioned, has the in-house certification. Takes about a month. For me, it took about a month, and this is about 3 to 4 hours a week. Obviously, I was doing this evenings and weekends outside of my work hours, so I still was able to get it done in about that time. I'm almost complete with it, and I'm just about 3.5 weeks in right now. So Microsoft Learn has some great resources. If you're a .NET Rocks podcast guy, one of the main guys from that podcast does a series called Blazor Train that's really good. And then Blazor University, I haven't dived into very deeply, but they look like they have some good stuff as well. So, sorry, we only have about 3 minutes left, but are there any questions, comments, concerns? Sorry, this has been kind of fast, and I wanted to demo a little bit more of how things are wired up, but hopefully that gives you just kind of a taste and kind of a taste of the Blazor way of doing things. No questions. All right. Well, okay. Okay, guys. All right. Best of luck, and hit me up. There's my email if you have any more things that you think of along the way, but appreciate your time.
Thanks, Quinn.